This video is for section 11.2. Our objectives in this section are to find the common difference for an arithmetic sequence, write terms of an arithmetic sequence, use the formula for the general term of an arithmetic sequence, and use the formula for the sum of the first n terms of an arithmetic sequence. So obviously this section is all about arithmetic sequences, and we need to start by defining what that is. In an arithmetic sequence, the same number and that number is called the common difference. Is added to or subtracted from each term to get the next term. So we're either adding the same number each time to get the next term or subtracting the same number each time to get the next term. So we're going to start by looking at example 1. It says to write the first 6 terms of the arithmetic sequence with first term 6 and common difference -2. So first term 6 means that A1 is going to be equal to 6. The common difference -2 means that I add -2 to each term to get the next term. So once I have one term, then I work with that to get the next term. So if my first term is 6, my second term, I'm going to take my previous term of 6 and I'm going to add -2. Or you can think of it as subtracting 2. Either way, I'm going to get 4. So A2 is equal to 4. Now to get the next term, it's going to be the previous term of 4 plus -2. So I'm always taking the previous term and adding the common difference to it. So A4 would be 2 plus -2, which is 0. A5 would be 0 plus -2, which is -2, and A6 is going to be -2 plus -2, which is -4. So if I look at any two consecutive terms, I can see that they're all decreasing by 2. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to see what's called the general form of an arithmetic sequence, and this is a formula that we can use to find terms. So if we want to find the nth term of an arithmetic sequence, and note that this formula works for arithmetic sequences only. It doesn't work for any sequences. It only works for sequences that are arithmetic sequences. With the first term A1 and common difference D, is A sub n equals A sub 1 plus n minus 1 times D. So this is an important formula. Obviously you don't need to memorize it for this class since you'll be able to look at this in your notes, but we're going to be using this formula for our next few examples. So we're going to start with example 2. It says to find the 8th term of the arithmetic sequence whose first term is 4 and whose common difference is -7. And so what you need to be able to do here is pick out the numbers and be able to plug them into the formula. So we have our formula, which I'll copy down here. A sub n equals a sub 1 plus n minus 1 times d. And so what we're looking for is we're looking for the 8th term. So that means n equals 8. Remember, n is the term number. First term is 4. So that's A1. And D is the common difference. So that's -7. So now I'm just going to plug these in. N is 8, so I'm looking for A8 is the 8th term. A1 is 4. N is 8. And D is -7. So I'm going to have 4 plus 8 minus 1 times -7. So do the math here. 8 minus 1 is 7. Do order of operations correctly. 7 times -7 would come next. That's -49. And 4 plus -49, that would be -45. So A8 is -45. Now, what this formula does is it gives us a way to find any term that we want without having to know the previous term. So back in example 1, if we knew the first term and the common difference, we could kind of go through every single term until we got the term that we wanted. So I could have used just the first term and the common difference and said, okay, what's the second term, what's the third term, what's the fourth term, what's the fifth term, and gone all the way up to 8. That wouldn't have been too much work, but if I wanted to find something like the 100th term, that would take a long time for me to go through all 100 terms in order to get to the 100th. Whereas with this formula, I just plug in the 3 numbers and then I can get that term directly. So next you should look at checkpoint problem number 2. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to look at a formula for the sum of the first n terms of an arithmetic sequence. And we use S here for sum, so we're looking for the sum S sub n. We use A for term and S for sum of the first n terms of an arithmetic sequence. Is S sub n equals n divided by 2 times a sub 1 plus a sub n. So again, you don't have to memorize this obviously for this class, but you need to make sure that you have this formula ready to use and are able to plug in correctly and use it. So a sub 1 here is the first term. And a sub n is the nth term. So however many numbers we want to add together, that's going to be our n. So we're going to look at example 4 here first. It says to find the sum of the first 100 terms of the arithmetic sequence 1, 3, 5, 7, etc. So we're going to start by identifying our variables here. Now for our sum formula, we need n, we need a sub 1, and we need a sub n. Since we want to find the sum, that tells us that we're going to use the sum formula that we just saw. So we want to find the sum of the first 100 terms. So n is 100. I can see my first term there is 1. Now, a sub n is a sub 100. And I don't know what the 100th term is here. So what I need to do is calculate what the 100th term is. Now I can obviously go through and list them all out, but that would take a really long time. So I'm going to use the other formula that we just saw using the a sub n equals a sub 1 plus n minus 1 times d. So my n here obviously is 100. I have my a sub 1 already, that's 1. The other variable I need to use this formula is d. So what number are you adding to each term to get the next term? Well, for this, that's going to be 2 because I'm going from 1 to 3, 3 to 5, 5 to 7. So I'm always adding 2 to each term to get the next. So that means that a sub 100 is going to be 1 plus n is 100 minus 1 times 2. 1 plus 99 times 2 is 1 plus 198, which is 199. So now that I have the 100th term, now I can use the sum formula. So this is kind of a tricky problem because you have to use one formula in order to get a variable that you need to plug into the other formula. So S sub n here is going to be S sub 100, sum of the first 100 terms. My n is 100 over 2 times a sub 1, which is 1, plus a sub 100, which is 199. So plug those three numbers into the formula and then do the math. That's going to be 100 divided by 2 times 200, and that is going to come out to be exactly 10,000. So next you should try checkpoint problem number 4. It's the same process for this problem, just with different numbers. So you're going to need to find the 15th term in this case, and then plug into the sum formula. So do this in your notes, check your answer, and then move on with the rest of the video. The last example that we're going to see in this video is example 5. And this is a sum where it's written in summation notation. And this one is actually easier than example 4. So I don't know why they put it after example 4, but it says to find the following sum from 1 through 25, and then you plug into the formula 5i equals 9. So again, we need to identify the three variables that are plugged into the sum formula, which is n, a sub 1, and a sub n. So since I'm going from 1 to 25 here, that tells me that I'm going to have 25 numbers that I'm adding together. So n is 25. My first term, I would plug in 1. So I'm going to plug in 1 for I. 5 times 1 minus 9 is negative 4. And then a sub n is going to be a sub 25. And now I can get that more easily in this problem because all I need to do is plug in 25 for I. So 5 times 25 minus 9 is 125 minus 9, which equals 116. So using the sum formula, sum of the first 25 terms is n divided by 2 times a sub 1, which is negative 4, plus a sub 25, which is 116. And then all I need to do is do this math. 116 plus negative 4 would be 112. And if I multiply that out, I get exactly 1400. So you always should come out with a whole number for these because you're adding a whole bunch of whole numbers together in your sum, so your answer should be a whole number. So next you should look at checkpoint problem number 5. Do this in your notes, check your answer, and then move on to the homework.